Okay, so I go on. Okay, let me on with the notes. Again, you horrible. Okay, let's target to hit up to 4.7 today. Okay, 4.7. 4.7. Wow. I think you should take a few more days to see. No lah. Gini. Langsung tadi. As in. Yeah, submit. Self-mark first. Self-mark first. Bye. I don't know what you're talking about. Huh? Yeah, big size mother is called maximum. Maxima. Which is the real life application of day-to-day function. So for example, okay, I'll give you a very simple example. Let's say you have about 100 meter of fence. Let's say short today you are about go New Zealand retired. Government tell you, okay, short, I give you 100 meter worth of fence. So your parameter is 100 meter. You can try to plant anything that you want. Plant like you can plant crops, apple trees, for example. So of course, Sean will be thinking, the best way for me to make more money is that my perimeter must enclose the maximum area possible, right? So I'll go to my fence. Okay, let's say for example, my perimeter is equal to 100. Now I have X and Y. Let's say I'm talking about maybe some sort of rectangular view. But it could be even be a circle. I do not know. But Sean says that okay, X and Y, you want to enclose the maximum possible, right? So that I can have a lot of trees inside my garden, okay, or boulevard. And then so area is equal to XY. Okay, area is equal to X times Y. Now the thing is, of course, then we sort of know that I want maximum area, I want maximum area. That means what do I need? I will be looking at some graph where the area and X, I will have some X that gives me the meters area. Oh, so now I look at, okay, that means if I need something like this, that means I need A X to be 0. I sort of need A X to be 0. I sort of need A 2 X to be less than 0. Okay, because I'm thinking about the second derivative test. So what does Sean need? Sean will need area in terms of X, correct? So can I have area in terms of X? So the thing is, I need one variable. The function must be in terms of one variable. Or the function must be in terms of one variable. So I know that it's add up to 100, right? So I know that 2x plus 2y is equal to 100. Which means that for fast forward, x is basically equals to 50 minus y. Not 50 or y equals to 50 minus, sorry. Y equals to 50 minus. Okay? Let's call this equation 1. Let's call this equation 2. Now, if I sub 1 equal 2, I can say that my area is 50 minus x times x, which is 50x minus x squared.
50x.
Yeah, sorry. Yeah. Just off my head. So after that, yeah. So if I will equate it to 0, right, that means 50 minus 2x is equal to 0. And x is equal to 25. Okay, what does that tell you? And most of the gardens and the plantation that you see, you ever notice why are they square? Because the fact is x is equal to 25. What is y equals to? 25, it actually encloses the largest area. So the best bet for you, Sean, if today if you go New Zealand, you want to buy a plantation, buy a square one. The square one is the most cost effective. Okay. Yeah.
Wait, so it's like in the problems we're just solving for x and y.
Yes, you're solving for x and y. So every question, application of maxima minima can also be brought into, for example, real life economics function. Okay, or profitability. What's the equilibrium point between the so for example, a lot of people they could be calculating. Let's say for example today, how many plates of chicken rice do I sell such that I make the maximum profit? It doesn't mean that the more I sell, the more I earn, because sometimes it can be a function of manpower, a function of the cost of eggs, a function of petrol. Yeah, so there are a lot of things that affect. Okay, the fact is you do differentiation next time, you will be applying this economics, you'll be applying this in finance, you'll be applying this in what else? Business. A lot of this actually do. Okay. So if you're still tuning in, well done to you. There's a report for you. You can pay attention to this part very well because it will be solved in the real life application part, which is 10% coming from term 2 week 8. Okay? Yeah. Yeah. Yes, it will be real life. The group will be real life. Okay, no, it'll be the group that you'll start at the start. See, yeah. Okay, okay, so let me go to question 4.4. Some of you could be at 4.4, so let me just go on. Talk about question 4.4. Question 4.4, if you have x squared equals to log x, right? Find the coordinates of the stationary point. You differentiate. If you are done with 4.7, you can try part 5 or you can do practice set. Okay, so after that, you will d1 dx is basically 2x. Differentiate the left. You differentiate the right, which is 1 over x. Right? One second, okay. So this is x bracket 2 ln x plus 1. Yes, Alex? Which question? Yes? V8 start. Groups the one that we did at the start of the year. Yeah. So 3 point. Point. The D1 is also. So you know that in the question, they already said that x cannot be 0. Is either x equals to 0, rejected, or 2 ln x plus 1 equals to 0, which means that ln x equals to negative half, and x equals to negative half. Okay, so from here, x equals to e half, right? So Kyson will know that this is the turn point. So after that, he will try value equals to e to the power negative half. I will be x squared ln x will be x squared ln x. Eventually, that gives you negative 1 over 2. Okay, so you can see that these are your stationary points. Okay, so the stationary point is e to the power negative half, and y is negative 1 over 2. Okay? Can So after that, then I do second derivative test. I differentiate second time. Remember yesterday's learning point? Second derivative small means your point is large, maximum. Second derivative large means your point is small. Minimum. Yeah. Positive is maximum and negative is minimum. No. Positive is minimum. So then after that, I check. So Kaisen go and differentiate a second time. What's the second derivative? One more time. 2 ln x plus 1 times 1 plus 2 over x plus 1. You don't need to simplify it already. You just have to be your own. Okay? Disruptive, I'm talking. Huh? Sorry? You see? Oh. So after that, then you sub x to be e power negative half. Okay, so Kaisa, after you do that, remember, okay, don't just write down. Some people like to write this. This one will get marks deducted. You need to find the numerical value. Okay? So I'm talking about question 4.4. You need to legit sub in. Yeah, don't scam people. There's nobody to scam except yourself. You scam me of the working, then teacher will scam you back of the marks. So it's not. People like to calculate. Should we write down the answer? Don't be so naughty, okay? Yeah, it's not yours, Isabella. Okay. And after that, so this is equals to 2, which is more than 0. So since second derivative is more than 0, since second derivative more than 0, then 1 over is minimum point. Okay, I'll just go around to see if any of you any help anywhere.
It's like this.
Yeah.
Then
So after you are done already, then you take second derivative. So this is like asking you to check the nature. Or like nature, so you see, you can do second derivative, do first. So
I need to find 2, right?
2 may not be if you only one.
Because they asked for the area of the triangle.
Okay, so after you found this, right, you need to test whether it indeed gives you the minimum. So if this gives you second derivative negative, then you say that it's the maximum. Because you don't want to waste your effort. If you start to found that it doesn't, then you are wasting your effort.
Second derivative even works for that.
Need to know what?
Local minimum.
Oh, yes. Sorry, local minimum point.
Because definition is bracket. I say
Because okay, I mean we just in general we just write down it's local. We just always write local. Unless you prove that it's global. Okay? Yes, then okay, then guarantee you.
Times again.
Ah, 4.5. So you differentiated already, right? After you differentiate your dy, yes, I believe you have x minus 1 power 4, that 1 plus x multiplied by 4x minus 1 power 3. So these two differentiate, you can factorize x minus 1 plus 4x. Okay, which is the same as 5x minus 1 x minus 2 power 3. Okay, now if I put this to 0, that means either So now you sub it in. Okay, or Aiden. I know it's been a hard thing. So I'm going to try to give you the answer, okay? So you don't when you got this, the answer is over 125. Have you found it? I bet you haven't. This is y equals to 0. Okay. You see, I know you so well. I know you are waiting for me to give you answer. Okay. Once I give you the y value, I hope that serves you well. Okay. Can I? Okay. Get to work, sir. Okay. Try to push up to 4.7. Okay. Yeah. Make sure that you understand. But remember, you must find the numerical value. Numerical value. Yes.
Two equations because you have one.
No need. You don't need two equations, just one equation. You always want, okay, so Sean, so you see, okay, whenever they say minimize the cost, Sean will be imagining, okay, minimize the cost. That means Sean will be thinking in his head, there's a cost as the vertical axis, there's an x, is minimizing the cost. He's minimizing the cost. So that means, right, what is Sean thinking about in his head? From the graph, he thinks about dc dx equals 0. Okay, he thinks about dc dx equals 0. So you need the cost function in terms of x. You need the cost function in terms of x. Okay?
Solve it via the equations.
Two equation. Okay, so you sub in. So you sub in. Okay.
There's two separate values. And sum.
Then why don't you consider adding since they are all in terms of x? Differentiate all.
But what cost of the sides and what are the fixed?
Add together. That's the total cost. Right? They're all in terms of x. When your one x changes, both sides and change, right? Add together. That's the total cost. Take the total cost to be differentiated.
Oh, so the total cost is just the x squared times this.
Yes. So the total cost in this case, what question are you looking at? 5.2. So 5.2, take a look. Okay, the height 2000 over x, right? For the top and bottom. Okay, so maybe you want to draw out. Top and bottom, the square base is x squared. Top and bottom 2x squared. 2x squared times 3, right? Fair. This is the cost. Plus, so on the sides is
4,000 over x.
4,000 over x. 4,000 over x, you multiply by 1.5. So this is the total cost. I'm doing dc dx for this. Okay, Sean? Can I? You want it? Maximum, minimum is very intuitive one. There's 4 sides. You have made a mistake? Okay, it's all good, don't worry. Okay, yeah, okay. So 6x squared, 8 times 1.5 is 12. 12,000 over x. Is that correct? Correct, huh? Okay. Then you all just differentiate this. Okay? Look at Caden, so happy doing maths. He's doing, as he's doing, he's smiling to himself. Zhe Kai also.
I got x equals 1,000.
Which one? X equals to 1,000. Is it 1,000 or 100? 27.93. Oh, you're so too fast already. You're don't so fast. You're pressure the rest. Do practice set first. Do practice set first.
Bro.
Hey, see. See properly. X is 10.
Oh, I divide by x, then over here I
Today I only aim for y'all to hit up to 4.7. If y'all can hit 4.7, that is the best. Okay, so do your best. Try to achieve 4.7. After 4.7, you can do practice set. If you need, I can airdrop you practice set. Yeah. Okay. If it's 0, it's inconclusive. If it's 0, right, then you have to use the first derivative. Okay, because when it's 0, it doesn't tell you enough. If it,
Sorry, what was the derivatives hash show is the point of the second derivative?
what's the derivative?
What were the second derivatives hash show the point of
likelihood it will show 0. It will show 0. It will show 0. Oh, but when okay, where you hear me out. Inflection, second derivative will show 0. But second derivative 0 doesn't mean it's inflection. Okay, can example, when two things imply each other, they are called equivalent. For example, if I'm a boy, I go to the boys' toilet. But if I go to the boys' toilet, does it mean I'm a boy? I may not be. I may be the cleaning auntie. Does it? So these two statements are not equivalent. So let me give you an example. Yesterday I got say. I'll just give you a counter example. 5 years ago, the question teacher asked, for example, can you come up with a function where the second derivative is 0, but it is not a point of inflection? So one example that we talked about yesterday, I think you all were thinking Alex and who else? Alex, I think Alex gave an answer. Who else gave an answer? Was it Hashini? Was it Aditi? Someone gave an answer. Zhisan? Was it Isabella? So the answer here would be y equals to x power 4. Now, if you look at y equals to x power 4, the graph, it looks like this, right? Now, it's very clear cut. We all know the turning point is 0, 0. 0, 0 is definitely a minimum point. But if Kate does this, she found that dy dx is 4x cubed. She equates to 0. She found that the turning point is x equals to 0. But when she did the second derivative, which is 12x squared, when she sub in x equals to 0, she got d2y dx squared equals to 0. Okay? But you can see that 0 but no, I spell only, not but x equals to 0 is not inflection. Okay? You can copy down for your use. Yes. Usually I stick to 0.1 to plus minus 0.1. 0.05 even safer. Okay, Zhisan, stop talking. Okay. Okay. Dora is thinking. Okay. Now very good one. Today everyone looking down at their notes. No one there to look up. Tyson looking down. Xavier looking down. Okay. Emily looking down. Okay. Look at everyone so hardworking, all looking down. Yeah. You need to check your answer for AFL. Which question? 2 and 3. Okay, question 2, the answer is negative 3/10. Question 3, the answer is 2.55. Okay? Second round. No. Okay, so A is 3.7. It looks okay, it looks okay, but you must try. I think something 2.55. Wow, Emily is so fast. Yeah. You so big size, muscular, the soft toy looks like it's being bullied by you. Being terrorized by you. Okay. That's how the soft toy tell me you want to see counselor. He's too scared by you. Okay, joking. Okay, I think quite some of you are at part 5, so I slowly write down the answer in a while. Okay, we just guys don't stress. Today minimum requirement hit 4.7. 4.7. Okay. Okay, so I slowly go through the answer for 4.7 for the purpose of recording as well. Okay, question maybe 4.6 first. Okay, 4.6 first. Okay, question 4.6. Now I'm going to do recording so that some of you watching will benefit. Okay. Question 4.6. If you differentiate, right, your dy dx, right, if you use a product rule, differentiate left side, I get 1. 4 minus x squared power half. Differentiate 4 minus x squared, power go in front, power drop by 1. Differentiate inside, I have minus 2x. Multiply the x. Eventually, you simplify, you get 4 minus 2x squared over square root 4 minus x squared. Okay? Then I equate this to 0. So the key thing is you realize that it actually is very useful to pack my dy dx into one singular function. Okay, I'm not leaving it like that. Why? Because remember last time I said if you equate your dy dx to 0, then this is easy. This is easy. So now I equate 4 minus 2x squared square root 4 minus x squared equals to 0. Because we are finding stationary point. To find the stationary point, dy dx equals to 0. This implies that 4 minus 2x squared equals to 0. Implies that 2x squared equals to 4, x squared equals 2, x equals to plus minus square root 2. Okay? So when x equals to square root 2, then you check y should be 2. When x equals to minus square root 2, y should be minus 2. You have two coordinates, square root 2, comma 2, negative square root 2, comma negative 2. Okay? So of course, I actually went faster on the parts that needed algebraic manipulation. But yeah, hang in there. I trust you all are able to maneuver well. Okay? So I look at this, guys. When I look at this, right? Now, do I really want to do a second derivative test? Oh, no, right? Because if I look at this, it's so disgusting. When I look at it, it's like, I don't even want to differentiate a second time already. So I do first derivative. Okay, I do first derivative. And square root 2. Then I draw my table. Okay? Slowly, I hope you all get that. So now I slowly show you all the answer. Okay? Question 4.6. 4.6. You all are, I think most of you are around there now. I'll go to 4.7 in a while. Yes. Okay, so Archie, I show you, okay, your dy dx should look something like this. So Archie, you try to pack all your dy dx, right? Because Archie, when you do dy dx, right, you find that you have two fractions, right? Yeah. So Archie, you try to pack both together to one. Then it's easy for you to solve this equation. You take two, you pack together, you get 1. Obviously, got 2, right? You do like product rule, you get one function. You pack one function. Then it will help you later. Because when you got 2, I think for some, not easy, like slowly maneuver. Slowly. So, okay, so for this question, right, then I ask you, just now I was saying, is it a good idea? If the question is difficult, to differentiate a second time. Repeat what I said. If the derivative is difficult to differentiate a second time, if the function if it's difficult to differentiate a second time, it's better to do first derivative. Right? Right? You feel what I say? Right? Now once you go through the pain, wow, Wow, look at this. I have used up 1.5 page. I still can't find my second derivative. Worse still, I don't even know if my second derivative is correct. So precisely, whatever I said to you face to face is right here. In this case, it is not easy to differentiate the first derivative. Sorry, first derivative. This is another advantage of knowing the first derivative test. 对吗？对吗？
What if someone thinks that it's easy to differentiate the first
I mean, then you try lor. But you can see, right? It's difficult, right? Okay, the thing is this. Why second derivative is good where if I see that the function is easy to differentiate a second time. Because it's convenient. Right? But remember there are also times where second derivative will fail. Right? Right, huh? All agree on this? Second derivative is not foolproof, right? Not foolproof. You don't like? What do you mean you don't like?
What if someone thinks the difference very hard and then has to make sure very hard?
I mean, all functions are differentiable lah. It just depends on how much you're using. But remember, in mathematics, we are about being lazy. Mathematicians always want to find the most elegant solution. Okay, stay focused. Okay, try your best. Commit to the answer. Think through the answer. Your bio test over already? No, tomorrow. Just now? Oh, it was just now. What's the difference between endoprime and exoprime? 4.5. First and second, there are two. One of the points I can use first. You see, when x equals to 1, the second derivative is 0. When it's 0, it's inconclusive. You understand? When it's 0, you don't understand.
Why are you using second?
Okay, listen. Okay, so now I go to question 4.5. Okay, if I look at this, right? Now my dy dx looks like this. Okay, let's make a judgment call from here. Is it easy to differentiate a second time? Yeah, so I'll do a second time. Okay, so I give you the analogy. Second derivative test is like the convenience store downstairs your house. First derivative test is like the NTUC or Giant. They need to walk about 5 minutes away. Okay, one is convenient, but it does not have everything. The other one is far away, but it has everything. So when you do, you always, if it's easy to differentiate, I do the second derivative test to check. Okay, good. I found that it works for 1/5. But when I go to x equals to 1, I got my second derivative to be 0. So it is inconclusive. When the second derivative is 0, it's a failure. You cannot conclude anything. It could be a maximum, minimum, it could be inflection. So that is why it's like you going to 7-Eleven, I want to buy 10 years series, then I realize it don't have. Then I have to go to Popular Bookshop, which is far away. Where do you stay? Hillview. Yeah. Oh, so it's like you go to 7-Eleven, there's no bread, you have to go to Bukit Timah or Beauty World to buy your DYS. Huh? Shut up lah, you. Just give me a context. Why you keep why you be so smart? Smart Alex. Sorry. I was aiming for the thing. Okay. Sorry. Okay. But you get the analogy? Then even better. You can use first all the way. If you use second, okay, in fact, if you don't want to use second, you want to use first all the way, it is fine. Not say useless. I mean, okay. Kaden, let me give you an example. Everything you want to buy, if there's a 7-Eleven downstairs your house, you just want to get instant noodles, will you walk 15 minutes to the NTUC or will you go downstairs and buy? Correct, right? So you want to buy instant noodles, you go downstairs NTUC, right? Right now. But if you want to buy 10 years series, you want to buy flowers for your girlfriend, you don't go to 7-Eleven and buy one. You go to all the way shopping center, right? Understand? One is convenient, but doesn't give you everything. Understand?
Yeah, 5 minutes and then would you rather try entire table or just do a second everything again? Yeah,
Ashini want to say something. She want to say something. Ashini want to say something. Alex, I saw her roll her eyeball when you talk. No lah. Ashini appreciates your wisdom. Liar. You're liar. Liar in purple. It's the lip. Liar in purple. Okay. So I go to 4.7, okay? So I go through 4.7. 4.7 slowly, okay. 4.7 differentiate. Okay, so if I differentiate y equals to x e to the power negative kx. dy dx. I think you all can do the differentiation. I just write it like that, e to the power minus kx. Okay. When you equate to 0 at stationary point, write this down. At stationary points, dy dx is 0. That means that I need 1 minus kx e to the power minus kx is 0. You know that this will never be 0. This is more than 0 for all x in R. Therefore, you have 1 minus kx equals 0, which is kx equal 1, which is x equals to 1 over k. Okay, so far? Now, x equals 1 over k, your y is equals to, you just sub y 1 over ke. Okay? So these two are, this is your coordinate. Okay? This is your coordinate. Okay? So this is your question 4.7. This is your stationary point. After that, you find your second derivative. Okay, you find, I'm so sorry. Okay, Songkran is over. Okay, after that, you find your second derivative. d2y dx square. d2y dx square. Okay, is 2k. Let me show you all the answer. Okay, after you find your d2y dx square, then you sub in. You sub in x equals to 1 over k. You get that it's less than 0. That's why it's a local maximum. Okay? Can That's for 4.7. I'm still not like into the part B yet. Okay, because you can see this is my dy dx. This is always positive, right? This one depends. If I solve this right, if this is more than 0, x must be less than 1 over k. So if x is less than 1 over k, this is positive, this is always positive. We put both things positive. But if x is more than 1 over k, this is negative, this is positive. They will be negative. So that's why what I'm trying to tell you is that this is telling you a story. The story is that 1 over k, right? 1 over k is here. On the left side, you can see it's positive. On the right side, it's negative. Okay, that is why it is a maximum growth. Okay, because I can tell you why am I the biggest? Because everybody on my left, the gradient is positive. Everybody on my right, the gradient is negative. Because I'm the tallest. Okay.
Basically, I want to work in it always down.
Correct, correct. Right a bit more. Right. Okay. So oral is assignment. Okay. The half. Tomorrow, then tonight do the other half lah. Okay, okay. The AFM kind. Okay, Thank you, class. Thank you, class.
She got